Hello students, how are you? I am R.K. Mavi, physics teacher here, and today I will teach you the Gauss law. Actually, Gauss law is very important law in your curriculum, and many questions are asked from this topic in JEE Main and Advanced. Suppose we have a body, we have a surface, and there is a charge inside it. So the charge will originate the electric field lines, and we take a small surface, very infinitesimally small surface, and electric field here is E, and area of this surface is ds. So flux through this small surface will be EDS, and total flux through inside entire body will be integration of EDS. So integration of EDS is 1 upon epsilon naught times the total charge inside the surface. What is the Gauss law? The total flux through a closed Gaussian surface, this closed surface is generally called the Gaussian surface in normal way. So the total flux through the closed Gaussian surface is 1 upon epsilon naught times the total charge inside the surface. Okay, here if we have a charge distribution like it, suppose this is charge Q1 and this is charge Q2 and another charge Q3 is outside, and if we take a point here, the electric field here is E and area of the surface is ds. So we will take integration EDS or E dot ds is Q1 plus Q2 upon epsilon naught. A very important point here, the electric field in left side is the field through all the charges. What charges? Q1, Q2 and Q3. Electric field is due to all the charges, but in right side the charge is only inside the Gaussian surface only, Q1 plus Q2. Why Q3 is not included here? I will let you know. If there is a surface and there is a charge inside it, Q, so electric field due to this charge will be like this. And if we have a charge Q dash outside here, so charge Q dash is outside the Gaussian surface. So if we draw the electric field lines, so electric field lines will be like this. Through the surface. So the number of lines entering the surface equals to the number of lines leaving the surface. So total flux due to this outside charge is 0. Okay. So this is the reason why in right side the outside charge is not included. Okay. Now some points regarding the Gauss law. Point number 1. The total flux through the surface does not depend upon shape and size of the Gaussian surface. Like this, if we have this Gaussian surface and total charge inside it is Q, so electric field lines will be like this, originating from the charge. And if we take another Gaussian surface of irregular shape and total charge is also Q, so electric field lines will be like this. So the number of field lines passing through the Gaussian surface in both cases are same. Number of electric field lines through this surface and through this surface are same. So the total flux does not depend upon shape and size of the Gaussian surface. Second point. Second point is this: the total flux through the surface does not depend upon location of charge inside it. If we have this Gaussian surface and total flux is like this and charge inside it is Q, and we have this another Gaussian surface and charge is here, not at the center, so electric field lines will be this. So number of electric field lines passing through the closed Gaussian surface in both cases are same. Okay. So what was the second point? Second point was that the total flux through the Gaussian surface does not depend upon location of charge inside it. Third point is this: the Gaussian surface should be closed and symmetrical. It means Gauss law is valid only for symmetrical surface. Fourth point is this: the Gauss law is valid for the fields which obey inverse square law. Inverse square law means if we have this charge Q and electric field at this point is E, so field is, according to Coulomb's law, KQ upon R square. It means E is inversely proportional to square of the distance. So electric field obey the inverse square law, then Gauss law is valid. So these are the 4 points related to the Gauss law. Now question based on the Gauss law. We have this square sheet of side length A and a charge Q is kept at a distance A by 2 at a perpendicular distance A by 2 from the center, and we have to calculate the flux passing through the sheet. So now this surface is not the Gaussian surface, because Gaussian surface should be closed and symmetrical. So what we will do here, we will kept 3 extra sheets. Now the surface is closed and this is the Q. So total flux through this Q will be Q by epsilon naught. What will be the flux? Total flux phi net will be Q upon epsilon naught, and flux through all surfaces of this cube is equal. So what we will do here, for flux through one surface will be Q by 6 epsilon naught. Why? Flux, this cube had 6 faces. and flux through all the faces is equal. So what we will do here, we will divide total flux by 6. So flux through sheet will be Q by 6 epsilon. Okay, I think you have understood this question. Next question. We have this cube and we have a rod of linear charge density lambda. This cube has side length L, linear charge density lambda, and this rod is we have to kept inside this cube. So what will be the maximum flux through this cube? The rod can have any length. Okay, so for this we have to calculate maximum flux. So for maximum flux, this rod should be kept as a body diagonal. Okay, from this surface, this point to this point. So we will keep this rod like this, and rod has linear charge density lambda. So what will be the maximum length of this rod? Q is lambda into root 3L, because body diagonal will have the length root 3L. So net flux will be root 3 lambda L upon epsilon. Okay, and in next lecture I will teach you the proof of the Gauss law and applications of the Gauss law. Thank you.